Hello good people, and welcome back to another math video, and a happy new year. This one on GCF, or greatest common factor, and prime factorization. So GCF stands for the greatest common factor, and that means basically the biggest factor, numbers that we'd multiply together to get the new number, in common that are the same. So you probably have seen something before with, if we were trying to find the GCF of 12 and 18, we might say, well, we could multiply 1 times 12, we could multiply 2 times 6, and we could multiply 3 times 4. And those would all give me 12. And with 18, I could multiply 1 times 18, I could multiply 2 times 9, and I could multiply 3 times 6, and nothing else. So they have 1 in common, they have 2 in common, they have 3 in common, and they have 6 in common. But only one of those is the greatest. So the greatest common factor between 12 and 18 is 6. We're going to do these a little bit differently. We're going to use a tree diagram because that is helpful when we have larger numbers to find the prime factorization. And we're also going to see some that have variables. So first we'll go over the steps. We had 3 steps. The first was to use a tree diagram that would give us the prime factorization of each number. The second step was to circle the numbers that were in common. The third step would be to multiply the common numbers, and that would give us the GCF. And it looks a little odd maybe to have a variable in there, but the process is really still the same. Let's take a look at our first problem. Find the GCF of 20x and 48xy. Well, first we'll find the prime factorization of 20. So I could break 20 into 2 and 10. Now 2 is a prime number. I'll circle that. I can't go any farther. Now let's see, I could break 10 into 2 and 5, and those are both prime numbers. So for 20, the prime factorization is 2 times 2 times 5. But remember, this is 20x, so I'm also multiplying by x. Now over here I have 48, so I could find the prime factorization of 48. I could do 2 and 24. 2 is a prime number, so I'm done on that branch. For 24, I could stick with 2, do 2 and 12, another prime number. I could stick with 2 and 6, and another 2, and 3 is a prime number. So for 48, my prime factorization there is 2 times 2 times 2 times 2 times 3, and then also times x times y. So remember, I had x and y as variables. Now I'll circle what I have in common. I have 2's in common, another set of 2's in common. Let's see, nope, nope, nope. My x's are in common, and that's it. So if I multiply what I have in common, 2 times 2 is 4, 4 times x is 4x. So the GCF, greatest common factor, of 20x and 48xy, sorry, I was a little short on room here, is 4x. Okay, here's another one. What's the greatest common factor of 30a and 54ab? Well, first I'll do my prime factorization tree for 30. Let's see, I could break this down into 2 and 15. 2 is prime. Could break 15 down into 3 and 5. Both prime numbers. So for 30a, I would have 2 times 3 times 5 times a. Now for 54, let's see. I could break 54 down into 6 and 9. and then I could break that 6 down into 2 and 3, both prime, and I could break the 9 down into 3 and 3, both prime. So for 54AB, I would have 2 times 3 times 3 times 3, and now my variables, times A times B. Well, let's see what I have in common. My 2's are in common. My 3's are in common. Let's see, no 5, no other 3. My A's are in common. So then if I multiplied what I have in common together, I do 2 times 3 is 6. 6 times A is 6A. So the GCF of 30A and 54AB is 6A. Alright, I hope that was helpful. A little reminder about GCF, prime factorizations, factor trees, and also starting out with some numbers that have variables in them. Watch the video a few times, and we'll see you soon. Bye-bye.